All right, let's look at the practice exam 3, problem number 2, part B. All right, so let's find the all inflection points of this given function. All right, so let's find the first derivative. So f prime of x is equal to, all right, so whatever inside the natural log, I'll put it here. So 3x squared plus 1. Take the derivative of that, put it on top, so that will be 6x. Right, so that's the first derivative. Let's take another derivative, so f double prime of x is equal to, right, 6 is just a constant, so we'll put it in front. Right, then we're going to use the quotient rule and square the denominator, which is 3x squared plus 1 squared, right? And derivative 6 is over here, so derivative of x is 1 times the bottom, which is 3x squared plus 1 minus top guy is x times derivative of the bottom guy is 6x again. All right, so we have that. Then if you simplify this, we'll get this. So 6 is already there. Then we have, let's see, you have 1, so I put 1, right? That will take care of this guy. Then combining positive 3x squared and minus 6x squared. So it's going to be negative 3x squared. All right, then the denominator is exactly the same. So I'll just copy that, 3x squared plus 1 squared. All right. Then since we're looking for inflection points, we're going to set the second derivative equal to 0. All right, so you can see that in order to make this whole thing equal to 0, we just have to worry about making the numerator equal to 0. So we have 1 minus 3x squared is equal to 0. All right, then we can subtract 1 from both sides, so you have negative 3x squared is equal to negative 1, and then we can divide through by negative 3, so we have x squared is equal to negative cancel out, so it's going to be 1/3. All right, so then we can take the square root of both sides to get x is equal to, right, plus or minus square root of 1/3. All right. All right, so let's put a number line here. So we draw a number line. All right. Then we're going to put the 2 tick marks for a negative square root of 1/3 and a positive square root of 1/3. All right. So we can just test any number. Let's see, less than negative square root of 1/3. So like negative 1. So we try f prime, double prime of say negative 1. Right? So you can see that the denominator is positive, 6 is positive. Right? So we have to worry about this guy. So if you put the negative 1 here, 1 minus 3 times 1, so it's going to be negative 2, so it's negative. All right, so we have a negative sign right here. All right, so it's a concave down there. All right, then we can try anything between negative square root of 1/3 and positive square root of 1/3. So we can try maybe 0. All right, if you put 0 there, 1 minus 0 is 1, so it's positive. So we know that on this interval, second derivative is positive. All right, then last one, we can try anything bigger than square root of 1/3. So I'll try a 1. Same thing, 1 minus 3, so that's going to be negative here. So we have a negative sign there, right? So if you look at the original function f, right, so we know that the concavity is going to be concave downward on this interval and a concave upward on this interval, then concave downward again, right? Which means that we're going to have here, since there's a concavity change, there's an inflection point. And here, there's a concavity change there, so it's an inflection point as well. All right, so let's find the y-coordinates of the inflection point. So we know that the x-coordinates are negative square root of 1/3 and the positive square root of 1/3. All right, so f of square root of 1/3 is equal to natural log of 3 times square root of 1/3 squared. Right, I'm gonna actually use a bracket here so that I don't get confused. All right, then plus 1. Alright, so you can see that it's going to be, let's see, square root cancel out. So 3 times 1/3 is 1 plus 1, so it's a natural log of 2. And you can see that if you plug in negative 1 square root of 1/3, it gets squared anyway, so you can actually get exactly the same value because you have a negative square root of 1/3 squared plus 1. Again, this is going to be 1/3, so 3 times 1/3 plus 1, so it's a natural log of 2. Right? So therefore, there are inflection points. Alright, so first one is positive square root of 1/3 and a natural log of 2. And the second one is the negative, so can I just do this, plus or minus? Right? So there are 2 inflection points there. Right? Alright, that's it. I hope that this was clear.